Okay, we will be discussing about mechanical energy. Mechanical energy. We will be using this abbreviation ME to represent our mechanical energy. The basic definition of mechanical energy, yeah, aside from it's another form of energy, but it's just the combination of our kinetic and potential energy. Again, um, it is possessed by the object with respect to motion or position. Okay, when we talk about motion, it's about kinetic energy. With respect to position, that's gravitational potential energy. So it's just the combination of these two energy to describe mechanical energy. We can also mathematically express mechanical energy as ME is equal to KE plus PE because it is just the sum of KE and PE. I am talking about mechanical energy. It's just the sum. Sum is the answer for addition. So we have to add kinetic and potential energy to get or to calculate our ME or mechanical energy. Okay? It's a kind of energy, so it has the ability to do work. Okay? It will only happen, it has the ability to do work as long as there is a conservative force. Okay, so I introduce you to this term, conservative force. Example of a conservative force is gravity. Within a system, for example, we have this popular illustration that I always use in my presentation. We have a ball on a table. Uh, this is a system. We call it as a system, meaning the table and the ball, it's part of that so-called system. And in order for mechanical energy to be conserved, okay, to be conserved, it needs conservative force. And remember, the example of conservative force is gravity. So there is only force of gravity acting on this ball, okay, as it gains potential energy because it's resting. So once it's resting, no velocity, so kinetic energy is zero while our potential energy is not zero. There is a value. It depends upon the height, mass, of course gravity is constant, and the height of that ball from the ground. Okay, let's say this is 1 meter, so that's going to be the height of the ball from the ground. Okay, so again, that's a system, your reference view of our object. We have a ball above the table with a height, so that's part of our system, and then we have gravity as the conservative force acting on it. So our mechanical energy, when there is conservative force, is conserved, or let's say constant. Okay, if and only if the force involved is conservative force. Because if not a conservative force, or we call it non-conservative force, it will either increase the ME or decrease the ME. But this time we will be focusing on a force which is conservative that is acting on our system. Okay? All right. So I will try to erase first this data here so that I can be able to put another special notes. I will give you a scenario. Let's say we have an apple. Okay, that's an apple. Okay. If the apple is still uh, holding its, I don't know what's the term. I think it's petiole, or I'm not so sure. It's still attached to the branch, or yeah, branch of the tree. That apple is obviously resting. Resting, no velocity. So therefore, kinetic energy is 0 joule, while our potential energy is non-zero. It has a value. Okay, it increase, or it's bigger than Ke because it's not moving. So uh, potential energy is stored in a resting apple. Okay, let's say that the apple's mass hypothetically is 3 kilogram, and then the height of that apple from the tree, we'll put it this way. Okay, let's say it's 3 meters here, and then let's assume that it's perfectly divided. So we have 2 meters here, we have 1 meter, and then the ground, of course, it's 0 meter. That's the height of the apple from the ground. So if we will try to look at it, the apple is not exactly at 3 meters, right? So we will try to make an estimation that the apple is around 2.8 meter above the ground. Okay, and this time we will try to know what will gonna happen if the apple will fall to the ground. Of course, there's a potential gravitational energy that acts on this falling apple. Okay, that's the falling apple there. Or let's say if the apple is in this position, once it falls, okay, let's try to find out what will be the mechanical energy, the total mechanical energy, the kinetic energy, or the potential energy of this illustration here. Okay, when the apple is still attached to the branch, it has no velocity, so no motion, kinetic energy is 0. We have a magnitude or value of our PE. Okay, it's a non-zero variable because it gains potential energy at a certain height. Now, what will gonna happen to potential energy if the height will decrease? Let's say the apple is now falling, and at an instant, the apple is decreasing its height from the ground. So let's say the apple now is in this position at 1 meter. It decreasing. So what will gonna happen to the potential energy? Okay, and since the apple is falling, it gains uh, kinetic energy, or it moves. So therefore, our potential energy will also be decreasing. It's directly proportional. Or if the height is increasing, let's say the apple is uh, still attached to the branch of the tree, so it increases its height from the ground. Obviously, from 0 to 2.8, it's increasing. The potential energy will also increase. Okay, I hope it makes sense. And Now, what if we need to find the potential, or not potential, but we need to find first the total mechanical energy of our system. Our system here is an apple attached to a branch, and there's a height from the ground. The apple is at around 2.8 meters from the ground, above the ground. So we need to find the total mechanical energy. Let's go back to the definition. It's just the sum of kinetic and potential. So we will use the formula ME is equal to KE plus PE. And remember that uh, at 2.8 meter, as the apple is still attached to the branch, it has no motion. So therefore, automatically, kinetic energy will be 0 joules. Why? Because the apple is still attached to the branch with no motion. So it has purely stored energy or potential energy. So we need to find the potential energy by using its formula. If you can still recall, we have mass times gravity and the height. Gravity on Earth, okay? Since we are on Earth, so gravity on Earth, it's equal to 9.8 meter per second squared. It's constant as long as the system is happening on Earth. Okay, obviously this apple is on Earth, so we will be using this value, 9.8. Let's continue. So, since it's 0, we can just omit that one from the equation. So we have mass of the apple. Mass of the apple is 0.3 kilogram. And the gravity, as I said, we have to use this gravitational value here on Earth. So we will have 9.8 meter per second squared. And then the height, where we have our apple still attached to the branch, so we agreed that it's around 2.8 meter. Okay, so if we will plug all these values in our calculator, we have 0.3 times the value of gravity, 9.8, it's constant, and we have the height that is 2.8 meters. So our answer will be will be 8.232. And the unit will be kilogram meter squared per second squared, or we can have 8.232 joule. Right? So again, just a short review. 1 kilogram meter squared per second squared is equivalent to 1 joule or J. Okay? So our answer, the mechanical energy possessed by our apple attached to the branch, it's 8, sorry, it's 8.232 joule. That's the amount of mechanical energy. Now, what will gonna happen if the apple falls? So when the apple will fall, uh, it's no longer resting. The apple now is gaining kinetic energy. So our kinetic energy begins to rise as the apple falls. So our potential energy begins to decrease until it will become 0 joule, especially if the apple is on the ground. It will become 0. But what if um, the apple is still at 1 meter? Let's say the apple is at 1 meter. meaning it's not yet fully on the ground, but it's still in 1 meter in this area. This is 1 meter. What if at an instant the apple is here? If we will try to have a snapshot and then we found out that the apple is at 1 meter, okay? So what will gonna be the kinetic energy if we need to find the kinetic energy of it? All right. So I will erase first some of the content here. So now we will try to find the kinetic energy at 1 meter. Okay, again, as the apple falls to the ground and we take a snapshot, and as we view it on our phone, it seems like the apple is at 1 meter before reaching the ground. The apple is moving, so we need to find out what is the kinetic energy at 1 meter. Conservative force, there is a presence of conservative force like force of gravity. So we can say that ME is conserved or constant. What's going to be the value of our ME? It's here. We calculated it minutes ago, 8.232 joules. So that's going to be the value of our ME. We will be using that, joule. Okay, so let's use the formula. The sum of KE and PE, it's the mechanical energy. And since force is conservative like gravity, so we can say that the ME value is the same, 8232 joules. It's the value of the total mechanical energy we just calculated. And then, all right, we need to find KE, so we have to copy kinetic energy there, plus the formula of our kinetic potential energy, that's mgh. Let's copy the value of our ME, then copy KE because we need to know what is the value of kinetic energy. All right, plus mass of the apple, 0.3 kilogram, and then gravity on Earth, that's 9.8 meter per second squared. And then the height now, it's 1 meter as being captured on photograph. So the apple is at 1 meter. Copy, because we will never do the operation yet on the left side of our equation. So copy KE as well. We will perform multiplying all these magnitudes here. Okay. I guess the answer, I will put it on the calculator. 0.3 times 9.8 times 1. The answer is 2.94 kilogram meter squared per second squared, or we can definitely change this into joule. Okay, next thing, in order for us to get the KE, we will isolate KE in our right equation. So we will move 2.94 to the other side of the equation. Okay, and since we have positive 2.94, as we move it, it will become negative. Okay, negative 2.94 joules, and then copy the constant value of our ME here. So 2.94 minus 8.232, the answer will be 5.292 joule. That's the amount of kinetic energy when the apple is at 1 meter. So it's 5.292 joule. Okay. And what if the apple reached the ground? Okay. So the ground is 0, no kinetic energy, and then no potential energy. Now, what if we will have to solve for the ME or the KE at 0? What if we will try to calculate the kinetic energy when the apple reached the ground? Kinetic energy as the apple reach the ground. Even without calculating, as the apple reached the ground, no velocity, no motion, KE is 0 joule. Now what about PE, potential energy, as the apple reach the ground? No height, no more height because it's 0 meter. As you can see, is 0 meter. So when you will solve it, you have 0.3 mass of the apple, you have 9.8, that's the value of gravity on earth, it's constant, and we have 0 meter. So any number multiplied to 0, it will result to 0. So it's 0 joule. Okay? So the mechanical energy as the apple reach the ground, let's say we have kinetic energy plus potential energy, and we have 0 joules because it's not moving, we have 0 joules because it's on the ground, so our result will be 0. Our mechanical energy will be 0 joule on the ground. Another very important information, as you can see, we calculated that ME is 0. It will only happen when the object reach the ground. That's 0 height, so potential energy is 0. And since it stops there on the ground, no motion, no velocity, so kinetic energy is also 0. That's why ME is 0. But in this case, please take note that I will put it there carefully. Please take note, before the apple hits the ground, before it reach 0 meter, before it hits the ground, not yet landed on the ground. So in that case, the ME is equal to kinetic energy maximum, because the kinetic energy is maximum before it reach the ground, before it will become 0, before the kinetic energy will be converted into 0. Before reaching the ground, kinetic energy is max, and that's going to be the value of ME, since our PE is equal to 0, right? So if PE is 0, so we have kinetic maximum. And apple resting on certain height of the tree. Okay, let's say apple is still attached to the branch, to the tree's branch. In that case, ME, mechanical energy, is equivalent to PE maximum. It's the maximum potential energy stored with respect to height. Okay? and then it will be converted to kinetic energy once the apple is falling down. So imagine, I will use another color. This is potential energy maximum. And then once the apple is going down, it falls down, it loses its kinetic energy. So kinetic energy will begin to decrease, while kinetic energy is being possessed now by a falling apple, it goes up, right? And then uh, it will speed up, and before hitting the ground, again, before hitting the ground, remember this one, the kinetic energy is max. All right, it's max, while your while the potential energy of the apple begins to be very, very low, okay, until it reaches the ground. PE will become zero and KE will become zero if it's not moving at all, right? Please remember this one. As the object falls to the ground, it speeds up. So I will have to show another color to show the speeding up of a falling object due to gravity. At first, look at that arrow, okay? So it speeds up when falling to the ground. That's an additional info.